Converting between logarithmic and exponential equations. It says rewrite each equation as requested. So remember, for every logarithmic function, there is an inverse function that is actually exponential. Let's write that relationship. Let's write that definition and expose that relationship. So if we have a base, b raised to the y gives you x, if and only if what? If and only if. Remember, if and only if statements in mathematics are two-way streets. If and only if y is equal to the log base b of x. Our input here is x. If it helps, you could even write the function notation. You can even write the parenthesis there. And so, let's state its domain. We know that x has to be greater than 0. You can only take the log of a positive number. And b cannot be 1, and b is greater than 0. So that is the definition of a logarithm. It has a relationship that is associated with some kind of exponential equation. Why don't we look at our exponential equations and we'll try to write a logarithmic equation. Make sure you're able to identify the base. The base is 6. And I usually start with the exponent. The exponent is negative 2 is equal to log base 6 of the argument, and the argument is 1 over 36. Let's look for another exponential equation. Let's do part E. The exponent's 4, the base is 3, so we need log base 3, and the only thing left is the input, or the argument, which is 81. Let's do part F. We start with the exponent. 0 is equal to log base 3 of the input, which is 1. So log of any base with the input of 1 is always going to get you 0. Let's go from log equation to exponential equation. We start with a base this time. 8 to the 0 power is going to get you 1. For part C, 8 to the negative 2 power gets you 1 over 64. Notice these are true equations that you're familiar with. Part D, start with a base. 4 to the 3rd power is equal to 64. And those are all true, and you know that already. Let's circle our final answers.